Hello to everyone and welcome to our 5th lesson. In this lesson we are going to connect a normal game controller or gamepad to our computer and use it in ROS. This is just a picture of my game controller. You can use your own or buy a similar one in internet for few bucks. As you can see, there is a joystick on the left side, which can be pushed in different directions, and another joystick on the right side. Finally, we have 4 buttons on the right side and 4 more on the upper side of the gamepad. The connection to the PC is over USB. In order to use the game controller in ROS, we need to download the appropriate ROS drivers. Then we run ROS2 run joy and joy_joy node. The node started and we keep it running in the background. The ROS node recognized the controller and started some topics. Let's look at them. If we look into the joy topic, we can see the information coming from the controller. So if I move now the right stick to the right and you look in the left terminal, you can see that the value at axis 0 is changing. Moving it in the other way, change the value in its sign as well. Moving the stick up and down changes the values of other axes. So then we have a second joystick on the right side. I move the stick to the right and left and the values change, up, down as well. Clicking on the cross pad, then the axis values change from -1 to 1. Pressing the buttons, I can see the values in the field buttons changing from 0 to 1. For instance, I click now the button 1 and its value changes. I click now button 2. I click button number 1 again, 2 again, 3 and finally 4. Every time I click on one of the buttons, it triggers its state from 0 to 1. Keep in mind that the joy node is running all the time in background. Now let's see how to use ROS by writing our node in order to be able to control or drive our robot using an external controller. Let's navigate into our last package, Telema, and let's create a new Python file called joystick test. First we import the usual ROS library and the joy message. From sensor msgs import joy. Finally, we import the remaining libraries as usual. The first lines are as usual the check that our file contains our main routine. Now we define the main function in our file. The structure is exactly the same as in the previous lessons. We define an object JR as instance of the class joystick read, which must be defined before. In this file we change the structure a little bit by using a try except block. In the try branch we spin the object JR created before. The except branch on the other side is executed when the shortcut Control key and C are pressed. We can even print out a line on terminal telling us that the program finished its job. Now let's define the joystick read class. The class definition has exactly the same structure as the old classes we created already. We initialize the node by invoking super_init followed by the name of the node inside the brackets. Then we create a subscriber, create subscription. We pass the kind of the message joy followed by the name of the topic, which we want to subscribe to. In this case, joy. Then we pass a callback method with the name getJoystickInput followed by the costs, in this case 10. Let's define some attributes, X for storing the value of the left joystick, Y for the vertical position of the same joystick, Z for the position of the right joystick, and W for storing the value of the vertical movement of the right joystick. Furthermore, we define A, B, C, and D for the buttons as well. We initialize all those attributes to 0 to update the later with the controller position. Let's define the callback. Pay attention here, since it is a method, the first argument is always self. Then we pass MSG. This is the message containing the joystick information retrieved over the topic joy. The x value now takes the first value of the list axes, so we write self.x equal msg.axes index 0. The same for the y value. Every time a message is retrieved from joy, this callback is executed. For z, same story. Pay attention to index the right value inside the axes list. We repeat the same for the buttons, self.a equal msg.buttons index 0, because we want the first value. Repeat the same for B, C, and finally D. Let's define a getLoggerInfo for displaying the retrieved values on the terminal. This is just to check whether our script is running correctly and whether the controller inputs are read or not. In future programs, we forward the inputs directly into our robot control system. Once we are done with our program file, we open the setup.py file inside our package. In another terminal, we open the setup.py file, and we define an entry point, which is the name of the program equal the name of the package dot the name of the file colon the main routine. Save the file and edit now the package XML file in the same directory. We update this file with the two missing dependencies, rclpy and the sensor message. In the workspace directory, we compile the package and start our program after sourcing the setup bash file. We type ROS2 run name of the package Telema and the name of the program test Joy. You can see all the value which are retrieved by our program over the topic Joy. We can recognize the timestamp on the left side in seconds and in nanoseconds. If I move now the left joystick in the left or right direction, then the value at axis 0 would change, but the change is reflected on the left terminal in the X value. Moving now the joystick in the vertical direction, it changes the value at axis 1. The same changes on the right and on the left terminal at the same time. If I move the joystick on the right side of the controller, then I change the values of axes 2 and 3. On the left terminal I can see that the implemented node fetched those values exactly as expected. Now let's try buttons. Clicking the first button, the value it changes as well. Same story for button 2, 3 and 4. Congratulations if you could follow so far. We will see you in the next lesson where we control a robot using an external controller.